simplify cos of arc cos minus a half, arc tan of tan pi, and arc sine of sine pi by 3. So the first one, cos of arc cos minus a half. Now this is kind of a function inside a function. You're actually finding the function of the inverse function of the input. So if you just take the inside bit, arc cos of minus a half, that converts an angle. So basically, if you find arc cos of minus a half, you find an angle such that cos of the angle is minus a half, right? Then once you have that angle, we're taking cos of that angle. So that's just going to get you right back to the start. So whenever you're finding cos of arc cos of something, or tan of arc tan of something, or sine of arc sine of something, there's no problem. It will just get you back to the start, because the arc cos in this case is just going to go to the angle, and then when we take cos of that angle, it's just going to go back to the value. So cos of arc cos of minus a half is just going to be minus a half. When we are finding arc cos of cos something, or arc tan of tan something, or arc sine of sine something, well, that's a bit different, because we're starting with an angle, and then we're taking the tan of it, in this case pi, and then we are finding the arc tan of that. So the issue is it's about this restricted domain and range of the functions, right? If you think about it, if we say, well, tan of pi, well, actually you can even work out, because it's quite simple. If we just draw a little unit circle, that's pi there, right? So you already know that tan of pi is 0. So tan pi equals 0. So then if we took the arc tan of 0, the answer can't be pi. If you consider arc tan of x, so range of arc tan x is, remember, the fixed domain of tan x for the purposes of defining the inverse function arc tan. Remember, it's fixed between minus pi by 2 and pi by 2. So the range of arc tan is going to be from minus pi by 2 to pi by 2, and it doesn't include those because they are asymptotes, right? So if we give an answer of pi, well, that's clearly outside of this range, so it can't work. We can put 0 into, we can find the arc tan of 0, that's fine, but we need to make sure we give an answer that's in the range. So if you look at this, well, tan of 0 is exactly the same as tan of pi, right? So what we can do instead, we could turn this into the arc tan of 0, and then we give us an answer in the range. So the answer, arc tan of pi equals 0. So it can't equal pi, because pi would be outside of the range of the function arc tan x. You do always need to consider that when you're doing it this way around, when you're finding sine, cos and tan of something, and then taking the arc sine, cos or tan of that. When it's this way around, there's never going to be an issue, so it's okay. Right, part C, we're finding the arc sine of sine pi by 3, right? Now, if we think about arc sine x, so when we are restricting the domain of sine x for the purposes of defining the inverse function arc sine x, that is, again, it's the same as this, apart from it could be those things. So the range of arc sine x is going to be, so it's between pi by 2, negative, and pi by 2. Okay, so this isn't going to be a problem, because that pi by 3 is within that range, so it's fine. So arc sine of sine pi by 3 of sine pi by 3, that is just pi by 3. Because pi by 3 falls within the range of arc sine x, whereas pi did not fall within the range of arc tan x, so we had to make an adjustment.